lesson 1 on polynomials. You're going to identify different types of polynomials, and we'll get to kind of know some of the lingo here. First vocabulary word is coefficient. That is a number in front of the variable. So for instance, you had 9a, 9 would be your coefficient. A polynomial is just a general name for a monomial or a sum of different monomials. That being said, we should probably identify what a monomial is. A monomial can be written as a number, such as 9. It can be written as a variable, such as a, or it can be a product of the number and or coefficient and the variable. So all of those are examples of monomials. Binomial, bi meaning two, so it is a sum or a difference of two monomials. Trinomial is a sum or difference of three monomials, so you're adding or subtracting monomials together. We'll come back and brush up on these other vocab words here in a second, but right now we're going to deal with some of these nomials. First things first is we're going to go ahead and determine whether each expression is a polynomial, and if it is a polynomial, we need to then go ahead and identify it as a monomial, a binomial, or a trinomial. So first things first, A here, we have 4y minus 5xz, and yes, this is a polynomial. The type of polynomial this is, well, here's one basically term, here's the second term. It's separated by a difference. Therefore, this type of polynomial is a binomial. And again, bi meaning two. Example B, negative 6.5. There is just one term there. There's no addition or subtraction happening. This one term, it is a polynomial. And the type of polynomial this would be is a monomial. Mono meaning one. The third example in C, a lot of people want to go ahead and say that this is a binomial because it looks like you have a couple different terms. This is not a polynomial. The reason why this is not a polynomial is because of the fact that you have a negative exponent here. So really, again, this is not a polynomial. So no, it is not. Reason being is because 7a to the negative third is really equal to 7 over a to the third when we get rid of that negative exponent. And a variable cannot be in the denominator to be considered a monomial, or in this case a polynomial. So again there, that's just reinforcing that this cannot be a polynomial. Next example, D, looks like it has 4 terms. Really doesn't, because you can combine like terms. Here's a positive 4x and a positive 1x. Basically, this would give us 6x squared. When you combine the like term, that would be a positive 5x plus 3. So 3 terms here. So this here, yes, it is a polynomial, and it is a trinomial. Anything more than 3 terms, you simply just call it a polynomial. But this has 3 terms. It looks like it had 4, but it really has 3 after combining. So it is a trinomial. E is not a polynomial. This is not a polynomial. Why is it not a polynomial? Again, because you have a variable in the denominator. So variable cannot be a denominator. Last example, F there, have 3 terms that we could not add or subtract together. This is a polynomial, and the type of polynomial this would be a trinomial with the 3 terms. Next portion here, we're going to go ahead and check out the degree of a polynomial. I'm going to have you look back at the definition here of degree of polynomial. As stated here, it says the degree of the polynomial is the greatest degree of any term in the polynomial. So this is regarding the exponent. Here's kind of naming the different types of the degrees of the polynomial. If the biggest degree is a 0, you'd have a constant. If the biggest degree is 1, it would be a linear, 2 quadratic, 3 cubic, and so on and so forth there for that table. Here's kind of how you break your degree out. In A, we have 6a squared b cubed plus 9. So you need to figure out using the exponents, what is the highest degree here that we have? And we know that basically all you need to do is add these exponents together here together. So you have 6a squared b cubed. This is basically 2 plus 5 or 2 plus 3 giving you 5. This here 9 is a constant. Okay, that is a constant. There is no variable there. So that would actually be just a constant. So the highest degree here is the 5th degree. So we would say that this is a 5th degree polynomial. So I'll just say 5th degree. B, if you look at it, it's a trinomial given. This here has a degree of 5. This here has a degree of 7 because 3 plus 4 would give me 7. And again, this would be a constant. So looking at this problem, this would be a 7th degree polynomial. It's named by the highest degree. So down there in C we are given a monomial. We look at the monomial. A has an exponent of 1. C has an exponent of 1. B has an exponent of 4. When we add these together, you basically have 1 plus 4 plus 1. And we have a 6th degree polynomial here. Degrees, the reason why we're doing degrees here is because it helps us write in standard form, which will be our next step. Why don't you go ahead and pause the video here in D, try to work through, try to list off each degree for each one of the terms here. We have a polynomial, so go ahead and pause it and try to work it out. As we check it out here, 2r t really has an exponent of 1, so this is really a 2nd degree. We look here, r has an exponent of 1, this would be a degree of 3. Check out the next term, we have r cubed t squared, this would have an exponent of 5, and 13 would be a constant. So this polynomial here in D is named by the highest degree. In this case, it would be a 5th degree. Now we'll take our degrees in action here, and we're going to write things in standard form of a polynomial. And we're going to also identify the leading coefficient. So what I want you to do is flip back to the front. Standard form of a polynomial is written with the terms in the order from greatest degree to the least degree. Those are the degrees that we just found out in those previous examples. The leading coefficient is the coefficient of the term with the highest degree. So first things first, I like to go ahead and figure out what the degrees are here. And if I look at A, I have a trinomial here. This actually has a degree of 2. This has a degree of 5. This has a degree of 1. So when I look at this problem, standard form is the greatest degree to the least degree. So the greatest degree would be the 9x to the 5th power. So that's what you'd write first, writing it in standard form. Followed by the next highest degree, which would be 4x squared, and that is a positive 4x squared. And last, we'd have a degree of 1, which is a negative 7x. And that is written in standard form. The next thing that you need to do is go ahead and identify the leading coefficient. Reminder, the leading coefficient, LC, is the coefficient of the highest degree. The highest degree would be x to the 5th, or the 5th degree, so the leading coefficient here is 9. We'll check out B real quick. Here we have a degree of 1. Here's our constant. We have a degree of 4, and we have a degree of 3. Writing it in standard form, our highest degree goes first, which would be a negative 9y to the 4th. Always carry the sign out in front, usually one of the biggest mistakes. And we have a positive 5y to the 3rd. And then we'd have a degree of 1, which would give me a positive 9y. And last, that constant at negative 9. That is in standard form. Your leading coefficient is negative 9. Negative 9, remember, it is the coefficient of the highest degree there, so there's that negative 9. And here's our answer in B. C and D, I want you to go ahead and work through. Why don't you go ahead, pause the video right now and try to work through them. First things first, listed off the degrees of each of the terms. Next, I wrote it out in standard form here. Then I identified my leading coefficient. D, I figured out all my degrees. So next part is to go ahead and write it in standard form. There's our answer in standard form, and then we identify that leading coefficient of -9. This will conclude Lesson 1, Polynomials, Types, Degree, and Form.